from a standard deck of 52 cards, what is the probability of drawing an ace or a club at random? Again, from a standard deck of 52 cards, what is the probability of drawing an ace or a club at random? All right, so let's take a look at this thing. Shuffled up, standard deck of 52 cards. That means we do not count the jokers, all right? So for those of you who are a little going like, what's a standard deck of 52 cards? Some people honestly don't know or haven't played much cards. So let's play this out for you. There are 4 suits. There are clubs. They are spades, hearts, and diamonds. There are 13 cards in each. We start with an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have face cards, which are called jack, queen, and king as they go up the ladder, all right? So those are the things. Some of you have played solitaire, you know what I'm talking about. Some of you played rummy, some of you played a little poker and all those kind of things. That's where we're coming from, those kind of a standard deck of 52 cards. Not the Unos, not the crazy 8 type things, but anyway, this is where we're going, all right? Now, what is the probability of drawing an ace or a club at random? Remember I said there are 4 suits, and one of those is clubs, all right? So in a club, there are 13 cards, okay? And those run from ace all the way up to the king, all right? Notice we have an ace right there. That's important. In a standard deck, there are also 4 aces because each suit has an ace. So we have 13 cards that are clubs. Here we have 4 cards that are aces. But what goes on here is you're saying, okay, so we're going to have an ace or a club. So a lot of us start thinking, okay, we'll add the 13 and the 4 and we got the answer. That would be true, except we have one problem here, one little problem. We have an overlap. There's the ace of clubs, which we have counted in both places twice. All right, so what we want to do, we want to take those 13 clubs and we're going to add the 4 aces. And what we need to do is take away, do a quick minus on the ace of clubs. And if you look at this, where we're going here, and by the way, that's 1. There's only 1 ace of clubs. So we're taking 13 plus 4 and subtracting 1. And remember what we got? We got 52 cards altogether. So I did get to bring my deck of cards here. Let's see if we can drop the bottom out there, guys, for me. Okay, thank you. So what we've got here is the chance of basically 17 minus 1 over 52. That's going to leave us with 62 out of 60. Let's try that again. 16 out of 52. Where did I get 62? My goodness. And let's take a quick look at the calculator, see what that comes out to in a percentage. And we'll also reduce the fraction here in just a second. All right, 52. That's a little, almost about 31%. We'll go with, how about it, 0.31 approximately. But reduce it as a fraction? How about it? Let's reduce it to a fraction. We can actually divide. I believe we can divide 2 in there for sure. Can we divide more than 2? Certainly can. We can divide 4 into those. We will end up with, it looks like, 4 out of 13. 4 chances in 13. And usually we tend to look at this because when we're counting cards, we're not really thinking about what's 31% going on. It's how about 4 out of 13, all right? Possibilities of getting those kind of cards combination.
For more math help, visit TNLearn.org.